Hi guys, welcome back. This week's a short week, so we're just going to review a topic. We're going to review trigonometry, we're going to review trigonometric identities, law of sines, law of cosines. You'll have a review worksheet due on Thursday, and you will have a test due next Tuesday. So before you guys start that, we're just going to review all of the information. So we'll start with trigonometric identities. These are different identities that are always true, no matter what the value of theta, what the value of x. While you are in this class, I don't mind if you use x instead of theta, because I know it's a weird letter to write. But once you move on to calculus or any higher math classes, you will have to know how to write theta, so you may want to get used to it. So some of our identities are the reciprocal identities, which is like sine and cosecant, and cosine and secant, and tangent and cotangent. Then we have cofunction identities, which are weird because it changes. It shows you which one is when they're going to be the same. Okay, even and odd identities. Then we have quotient identities, which are just the representation of tan and cotangent of theta. And then we have Pythagorean identities, which are used in other times. So all of these can be used to prove why one value is equal to another. So I'm going to show you two examples on this video. You'll have some examples on the review worksheet, and you'll have some on the test, okay? So our first one is going to be cosine of x plus sine x tan x equals secant of x. So the first thing that we want to do to get that solved is we want to take tangent of x and make it sine x over cosine of x, okay? So we're only changing the left-hand side on this, and then we can multiply these together. We have cosine of x plus sine squared of x over cosine of x, okay? Now, I can multiply my first term, cosine of x, times cosine of x of cosine of x. That's going to change it all to be cosine squared x over cosine x plus sine squared x over cosine x. Now I combine that as one fraction, sine squared of x plus cosine squared of x over cosine of x still equals secant of x. Okay, using my Pythagorean identity, sine squared of x plus cosine squared of x equals 1. So 1 over cosine x equals secant of x. And since that is our identity and our definition of secant of x equals secant of x, and this is proven. Okay? Now, on to our next example. We have 1 minus cosine squared of x equals tan x, cosine x, sine x, all of these multiplied together. So, our first step for this one, we're going to change the left-hand sign to be sine squared of x using that Pythagorean identity. Then, for this example, we want to move things on both sides. On the test, I don't believe I did anything with that. You'll only be working with one side at a time, but this shows you how versatile these things are. So now I have sine squared of x on my left-hand side. We're going to change tangent of x to be sine x over cosine of x, still multiplied times cosine x sine x. All right? So now I have sine squared x equals sine x over 1 times sine x over 1. Okay? So then I have sine squared x equals sine squared x over 1. And this becomes sine squared x equals sine squared x. All right? So I can do this. I didn't explain this previously. I can do this because my cosines cancel out. So then I have sine squared x over 1 times sine squared x over 1. And that's how we simplify all that. All right? So using any method possible, we want to make sure the left-hand side equals the right-hand side. And this proves that 1 minus cosine squared x equals tan x, cosine x, sine x. All right. I know it's a little bit tricky, so don't get too caught up in all the different values. You'll be able to use the sheet of values or this PowerPoint on the test. Okay? So now we're going to review the law of sines. Again, the sine definition, it's a trigonometric ratio, opposite side over hypotenuse, SOHCAHTOA. Law of sines, I'm sorry, I need to change that, is good for proving congruent triangles using angle, angle, side, or side, side, angle, and angle, side, angle. The upside of it, it's a simple ratio. It's not too hard to work with. And the downside, it can't be used if only sides or only angles are known. Okay? So, my law of sines, again, I have to fix that, I'm sorry. we have to make sure our calculator is in degree mode. If it's in radian mode, we will not get the correct answer. And my ratios are A over sine A equals B over sine B equals C over sine C. All right, so one example here, we have this triangle. We're going to be looking for side B. So my ratio, I have side A over the sine of 43 equals side B over the sine of 57. So now I'm going to plug in my side A, 4.56. I'm going to multiply both sides by sine of 57. Okay, so now B equals 4.6 times sine of 57 over sine of 43. And once I simplify all of that out, B equals 5.61. Okay? Now I'm also going to give you a word problem example, and I'll show you the answers for both the questions in this word problem. On the test, there will be 4 word problems for you to work through. Okay? No matter what, you will be given the triangle for it. It's just practice to see what the word problem is asking for. Okay? And some real world examples of this. So a large helium balloon is tethered to the ground by 2 taut lines, 2 super tight lines. One line is 100 feet long and makes an 80-degree angle with the ground, and the second line makes a 40-degree angle with the ground. So the first question we're going to answer is, how long is the second line? Okay, so this is our picture. I don't have the degree sign on my angles, but that's what it is. We're looking for x in this question. X, how long is the second line? So to do that, we have sine of 40 over 100 equals sine of 80 over x. Now I have x, I'm going to multiply both sides by x, and then I'm going to multiply both sides by 100. So I have x sine 40 equals 100 sine 80. X is going to equal 100 sine 80 over sine of 40. And that will simplify to about 153 feet. Again, we're rounding to the nearest foot in this question. All right. Now, same question, or same problem, but how far apart are my 2 tethers? So now I have that my x equals 153, and I'm looking for y. So for this, again, I want to use sine of 40 over 100 equals sine of 60 over y. Y sine of 40 equals 100 sine of 60. So y equals 100 sine 60 over sine of 40. And my y will be about 135 feet. Okay? One thing I want to point out is, you'll notice in our original definition of the law of sines, it was the side length over our sine values. Since I flipped both sides, this is still a true statement. Okay? Next, we're going to go back to law of cosines like we learned last week. Again, it is still adjacent side over the hypotenuse. It is good for proving side angle side and side side side, and is equivalent to the Pythagorean theorem for all triangles. Okay? Again, we want to make sure our calculator is in degree mode, and these are our 3 setups. And one example I have for us, it's a right triangle, but we're still going to use law of cosines. So we're going to use a squared equals b squared plus c squared minus 2bc over cosine a. Okay, I'll start plugging things in. A squared equals 6 squared plus 10 squared minus 2 times 6 times 10 times cosine of 90. Okay, so now I have a squared equals 36 plus 10 squared minus 2 times 6 times 10 times cosine of 90. I have a squared equals 36 plus 100 minus 2 times 6 times 10 times cosine of 90. A squared equals 36 plus 100 minus 12 times 10 times 6 cosine of 90. A squared equals 36 plus 100 minus 120 cosine of 90. That's going to simplify to 36 plus 100 minus 120 times 0, which is going to be 0. So a squared equals 136 when I add my 100 plus 36. And finally, taking the square root of both sides, a equals 11.66. Okay? Now I have a word problem for law of cosines. A boat leaves Kingston and heads due east for 25 kilometers. At the same time, a second boat travels in a direction of 30 degrees southeast from Kingston for 15 kilometers. How far apart are the boats at this moment when they reach their destinations? So, we're starting at A, and we're moving down and with an angle of 30 degrees. So, we're looking for side A. We're going to use the same setup as the last equation. Now I'm going to plug some things in. A squared equals 15 squared plus 25 squared minus 2 times 15 times 25 times cosine of 30. A squared is going to equal 225 plus 625 minus 2 times 15 times 25 times 0.8660. A squared equals 850, that's adding the first two, minus doing all that multiplication, 649.5. A squared equals 200.5. Taking the square root of both sides, A is 14.2 kilometers. All right, make sure you include your words in the answer for a word problem, even if the PowerPoint did not show them. All right, and just to close this up, I am here to help you guys. Before taking this test, please let me know if you were confused at all about anything. I'm willing to email you back, post another review question, go over the problems again during our Google Meet, okay? Email me at brobinson@sapublicschools.com. I can even set up an individual practice session with you guys if you feel uncomfortable with it, okay? And don't forget, this week is a little bit different. We will only be having our Google Meet on Thursday at 11 a.m. We do not have 2 this week. Your assignments are the trigonometry review worksheet. That's going to be due Thursday at 11:59. And the trigonometry test is going to be due Tuesday, June 2nd by 11:59 p.m. Okay? Please, again, reach out if you have any questions. And